what you've been able to do by setting up a circuit where you've got a source of alternating current, you've monitored the voltage and kept that constant, and we've seen what effect changing the frequency has on the current running through the inductor, and you've plotted frequency and current. Well, in fact, some of you didn't even need to plot that, because what kind of shape were you getting as you increased the frequency? Done? Okay, so it comes up like that and goes down like that. As you increase the frequency, we're finding we're getting less and less current going through. So that graph there isn't really telling us a relationship. In terms of physics, we're always looking for something you can actually put into an equation. The second graph that you've plotted is frequency with 1 over the current. And what was your shape of graph for that you're getting there, Chris? Yeah, it starts off quite linear. It tails off a bit at the end, but generally, at these lower frequencies, you are getting a linear relationship. So in general, the current is proportional to 1 over the frequency, because you get the same shape graph if you were to plot 1 over f with current like that. That would be a straight line graph through the origin. So we've got an inverse relationship. That's why, mathematically, what would you call that curve that you were getting if you plot a current against frequency? Yeah, so you get, that would be a hyperbola graph of y equals 1 over x. In this equation here, you put in two constants. What constants appear in that to give you an equation? Okay, so we get I equals 1 over 2 pi f, and also the other constant is to do with the number of coils and the makeup and the material, which is the inductance. So 1 over 2 pi fl. That you can rewrite as 1 over xl times the frequency, where x is the reactance, 2 pi l. And reactance is analogous to resistance for a resistor. So you can, in an equation, put that V is equal to I times XL, and that would actually give you the voltage across an inductor if you knew the current and you know the thing's reactance. But that's not actually part of advanced higher. So where would you want to use an inductor? Why? Inductors are good at, if you've got an inductor in a circuit, what kind of electricity is going to get through, what kind of electricity is not going to get through. Yeah, okay, so you get a lot of DC. You'll get DC backwards and forwards here, no problem. What it won't allow through is AC, and certainly high frequencies. So if you've got something connected up and you want a pure DC, say it's a bit of electronic equipment, and you want to prevent in your DC any spikes in the line due to interference, if there's an inductor, and in automotive electronics, we would actually call that a choke. So you might sometimes hear a coil of wire in series with say a car stereo referred to as a choke, because it chokes off the AC in the circuit, and you end up with a much cleaner DC. Also at higher, we talked about how if you have a capacitor in parallel in between a power supply and a load, the capacitor can act as a smoothing capacitor to even out any of the irregularities. So between the two of them, between the inductor L and the capacitor, you end up, in terms of DC, with DC smoothing. The other thing that you can use it for is, say if you've got loudspeakers and you want low frequencies to get to your big woofer loudspeakers and just high frequencies to get to the smaller tweeter loudspeakers, then an inductor can be used for that as well, where you're using it as a filtering mechanism. So the inductor, if you've got a range of frequencies, high frequencies and low frequencies, put that through an inductor, into your loudspeaker, then in that case you'd only get the low frequencies through, leaving the high frequencies maybe to go through a capacitor to a second loudspeaker, where this would be the tweeter for high frequencies, and this would be the woofer for low frequencies. So crossover networks involve this kind of combination of inductors and capacitors. In fact, I've got one I'll show you in just a moment.